definitely want, I wouldn't try and squeeze this on the note card yet because you don't know how much you're going to add. Of course, you can use multiple note cards. But you have a symbol that looks like this. This is the population mean. You have a symbol that looks like this. This is the population standard deviation. So that's like everybody. And then you see X bar, that is your sample mean. And if you just see like an S, that would be the sample standard deviation. So that would probably be important to know if we had symbols for you. Okay, that's pretty straightforward. I just want to knock out any equations that we know that would be important. Sample distribution, M&Ms. We didn't do 5.2. So 5.2 we skipped. Okay, so don't stress about anything there. Then we have a symbol that looks kind of like this. So this is the sampling distribution mean. And we would also have this. So that's the sampling distribution. Standard deviation. Okay. So those are all pretty legit stuff. Remember, this is going to change. So they call this sometimes a standard error. So it changes our standard deviation from time to time. Okay. Can I move off the screen, or is anyone still copying? Good. All right. Then we had something that was this, which was, hey there. So when we have this was our mean, and this would have been the number of routines or tests. They call it number of people, things. So that would change from time to time. So we would use this if we had if they asked us to make a new normal curve. Remember, the mean stays the same. And then as n increases or decreases, and those of you coming in, I'm going over 5.1 to 5.5 worksheet that I had given you last week. If you don't have one, I'll give you note cards to come grab them. Luckily, I said that you would be used to this stuff because you ice skate, so you're always on slip and slide stuff. But the skates aren't on the car stirrup. You're right. All right. Let's see. I'm just kind of going through doing some. Then we have the letter P. This is the population proportion. We have P hat, which is the sample proportion. And we have mu P hat. This is the average proportion of all samples. And then we have this P hat, This is the standard deviation of the proportions of all possible random samples, which is called the standard error. All right, so friends who came in late, we're going over the 5155 worksheet I gave you last week. If you need an extra copy, there's some up here, as well as note cards. Then we might see something like this, U P hat is equal to P. So these very random samples, sample distribution with mean U P hat, standard error. So the standard error might also change to this of U P hat, where we have an equation that looks like this. And so what you recall on this is the P is some sort of percent. You want to make it a decimal, a true decimal, not with a percent. Okay? What's that? Yeah, it's 1 minus P. So usually what happens is they might say that you have 75% of something, which is 0.75. And let's say we had 100 people that you're serving. And I'm just making up arbitrary. So if we were to plug into this, we would get root 0.75, 1 minus 0.75, all over 100. And then obviously use a calculator to determine what our new standard deviation would be. Okay? And this would give us our answer as a decimal. But note, could be a percent, could be made a percent. So these are all just things that I'm just kind of focusing on. Okay? So, random sign of independence. And then we want to know if the sample size is large enough. So normally, sample of 30 is where, and above, is where we're trying to get to. But remember, we also have a test. If this and this, if they both become yeses, n is the number of items, p is the proportion, 1 minus p is the complement of that. So if this takes place, if the sample size is large enough, assumption is met if both the following are true. So if these are both true statements, sampling distributions proportions are more skewed. So if these are both yes or both true, this means we are able to create a normal distribution. Okay? So if one of those is a false or both are false, it's not a normal distribution. It's a distribution, but it just doesn't form the normal scenario. Okay, so that's basically as far as the definitions. Now, I had gone over 1 through 5 on this worksheet. Okay, 5.1 to 5.5. So take a look at the front page. Are we okay with the information on there that I had gone over? Is there anything you need me to recover or just go over? Of course, you could find the video. We did this, I believe, Friday. So the Friday's lesson, it might have been Thursday, I can't remember. I think it's Fridays. Friday?
Friday you did 1 through 5.
Okay, Friday I did 1 through 5. So if you want to look for the 1 through 5 stuff, if we're not going to go over any, which is fine, It'll be on Schoology for this past Friday. So you just have to find the link for this past Friday, and you can watch that video. You know, nice thing is it's YouTube, so you can change the speed. You change it to like 2.5 times the speed. You get done with it real quick, but I talk like I'm Mickey Mouse because it's real fast. All right, so let's go over to number 6 on this worksheet. Everyone good? Everyone has that worksheet? Okay. So assume that is known that 30% of the population has type A blood. We took a random sample of 80 people and measured their blood type. Calculate the mean and standard deviation. Well, they gave us the mean. They said 30%, so we're going to call it 0.30. That's given. Okay, then we have to find the standard error, aka standard deviation, when we're dealing with 80 people. Okay, so what I'm going to do is I'm going to do the square root of 0.3, and then I have 1 minus 0.3, all divided by 80 because that's what our sample was. And so if you do this math, it's going to come out to 0.051, which would be 5.1% if it was asking for percents. Okay? And then for number 7, if we do the normal distribution based on our new information, we know that we have our mean, which is going to be 0.30. And then if I add, I'm just going to add 0.5, which is totally fine. And subtract 5, 0.20, and 0.15. Okay, so that would take place pretty easily. Okay, so if you can do something like that, this is based on this new information. Okay, getting that using your mean as the very center of your normal curve. It says calculate the probability a random sample of 80 people, or 80, will produce fewer than 25% with type A blood. So we're looking here. This is the area we're looking for. So remember, this is going to be normal CDF on the calculator. And when you plug it in, we want less than, so we want a really small number here. Okay, far to the left of 0.3. So we could pick, like -10 or -100 or -10,000. Doesn't really matter what we pick. It's going to give us pretty much the same answer unless you pick something too close to it. So if you pick 0, you might not get quite the answer we're looking for. The next part would be 0.25 because we want up to the 25%. And then the 0.30 would be what the mean is. And then the 0.051 is our new standard error. And if you plug that in, of course, that's all. If this was done correctly, right, -100, 0.25, 0.30, 0.051. If we did that math, we would come out with about 0.163, which is 16.3%. I'm not too concerned if you leave it at 0.163 or 16.3. It's your choice. But that's how much area is under the curve. So calculate the probability random sample had fewer than 25% with this type of blood. We have a 16.3% chance, or 0.163 probability, something like that would allow you. Does that make sense so far? And again, if you have once you use the calculator, if you can't remember where to find normal CDF, ask me. I'm happy to help you to guide you through it. And then we want to know, is 80 large enough for the sample size? Well, we know we have to be above 30, so 80 is above 30. So we're pretty happy about that. 80 is greater than 30, so there is a chance. But then we have to plug in. We have to go 80 times our 0.3, and if that's greater than or equal to 10, and we also have to go 80 and then 1 minus 0.30, and if that's greater than or equal to 10, if you did the math on both of these, you're going to find out that these are both true. So this is a large enough sample size to say that we have a normal distribution. And that's just using that equation. Does everyone feel comfortable with these? Okay, and again, do you have the notes on a note card, or will it be on a note card where you know you can find it? I hope so. And again, if you have to use multiple note cards, you're not going to offend me. I mean, I realize you're sitting there, you're going to get some sort of degenerative wrist and finger disease if you're trying to scribe it so small to put everything on there. And then it says state the central, so we're up through number 9. So number 10 says state a central limit theorem from your notes or in your own words. Okay? So number 10, if I put it in some sort of words, this is not exact answer. So a sampling distribution will always be normal if the sample size is large enough. Okay, and then a few things to think about is 30 is what we really are trying to get to, but we also have the test that we would say, n times p, if that's greater than or equal to 10, and n is 1 minus p is greater than or equal to 10. These also have to be true in order for that to take place. So you're looking saying, hey, I have a sample that's bigger than 30. Great. Does it satisfy those two tests? If that then takes place, you have the 30 as a check mark or bigger. So you're like, oh, I have 170. 170 is great. If I go 170 times the percent as a decimal, if that's greater than 10, and the 170 times 1 minus whatever the percent is, or the decimal, if that's greater than 10, those are both true, then it means we form a normal distribution. So that is basically everything that I would have on, if you orchestrate that to make it work appropriately on your note card, great. I do have 8 calculators that you can borrow. If you have the TI 83 or 84, please bring it, or borrow from a friend. That way we don't necessarily have to show calculators. You don't have to wait for someone to get download a calculator. And then, so tomorrow will be our quiz. That's Wednesday. And then whatever I had assigned yesterday from the 5-6, right? Is that what I taught yesterday? 5-6. That'll be due on Thursday. Make sense? Everyone feel good about it? There's a couple of you that still owe me test or quizzes from the beginning of the year, or the past couple weeks. So if that's you, let's not wait forever. Josh, the small quiz that you have is pretty quick. Ren is pretty quick, okay? Swan's not here. And then Josh, you have the following people. So Josh, that's 5-1 to 5-3. Kale, 5-1 to 5-3. Ren, 5-1 to 5-3. Aaron, who's not here, 5-1 to 5-3. Megan K, who's not here, 5-1 to 5-3. Kenna H, who's not here, 5-1 to 5-3. Kim, 5-1 to 5-3. Rashim, 5-1 to 5-3. If you are one of the 5-1 to 5-3, if you wanted to come in with a couple of you or all of you, if you can all orchestrate a time that works, you're welcome to come in and do that one together. Okay? But the small quiz that you two have, it's real small. I mean, just trust me on it. It's on basically, it's a Venn diagram. It's a contingency table, pretty straightforward. Tree diagrams, so that's what that first quiz would be. It probably, if you have the notes for it, it'd probably take you 15 minutes. Okay. All right, I'm going to stop recording now if that's okay with y'all at 19:38.